Alright, so let's start with this series. So the first question, it's an easy one, is contains duplicate. Basically, you can read the question. It basically means that if we are given with a vector and if a number is repeating at least once, so it means that if a number is repeating, if there are duplicates in the vector, then we return true, and if there are not, then we return false. So it's a straightforward question. Now let's think about it. You can look at these examples. The first examples, since one is appearing twice, then we return true, and in this example there are all unique elements, so we return false. So uh, there's a data structure which is called set. If you know what it is, then you have solved the problem. However, what we will try in this series will be to, if possible, if I know more than one solutions, then we will talk about it and discuss their time and space complexity. Coming back to it, since if you know set data structure, then the problem is solved. So a property of set is that it cannot contain any duplicate, and that is exactly what we need. So let's start with defining our set. Set are of two types in C++. One is unordered set and one is set. Unordered set is there is no order in that set, and by default the set is ordered, which means that the element will be in sorted order. But in an unordered set, it won't be in sorted order. So let's name our set as st, and I have defined the data type as int, which means that this set will only contain integers. Now the idea is to basically one by one insert all the elements of my vector to this set. Now if all the elements are distinct in my vector, then let's say there are 4 elements in nums, so there will be 4 elements in my set if I insert them one by one. So if the set size and the vector size is equal, then I can say that all elements are distinct, thus there are no duplicates present. So we return false. If my set size is less than my vector size, then it means that there is a duplicate present in my vector. So let's code it up. So we traverse through our vector and we insert them in our set one by one. After inserting, we just compare. If my set size is equal to my nums size, then it means that there are no duplicates present. So we return false, else we return true. Now let's see if it runs fine or not. So the example test cases are getting passed. Now let's submit it. And yes, we are able to pass it. So let's discuss about this solution's time and space complexity. What is the time complexity? What do you think? So we are using a set and we are traversing through our vector and we are inserting it one by one. In an unordered set, you can say that the insert operation on average takes a big of 1 complexity. So, and this we are doing n times, where n is the number of elements in my vector. So the time complexity of this solution is nothing but big O of n. And since we are using a set here, the space complexity, at most what can be the size of set? If all elements are distinct, then our set will contain the number of elements in the vector, which is equal to n. So the space complexity will also be n. So can we do better than this? I am not sure if we can, but I can think of another solution. Instead of set, what we can do is that, suppose we didn't have knowledge of set. There are multiple ways of solving this question. We can either use a frequency vector in which we score the frequency of elements present in a vector, and similarly we can use an unordered map. We'll do the same thing. If we are using a map, we will insert one by one, we will insert the number which is present in our vector to the map. If at any point an element is repeating, so the count will increase to 2. That is, the frequency of that number will increase to 2. Then we for sure know that that element is a duplicate. So now let's code that solution. As I said, we will have a map. If you know map data structure, the first is the key and the second is the value. So let's say that our map name is MP. We traverse our vector and we insert the value one by one. So we have to keep track of the frequency. So at first, MP of IT for everything is 0. When we see 1, the first element here, MP of 1 becomes 1, MP of 2 becomes 1, then MP of 3 becomes 1. And then again when we encounter 1, MP of 1 was already 1, and now we are incrementing 1 to it. So MP of 1 becomes 2. So if at any point this value is greater than 1, which means that it is containing a duplicate. So we return true, else we return false. Now let's run and check it if it runs fine or not. Okay, our example test cases are getting passed. Let's see submitting it. Yes, we can pass it. And what will be the time complexity of it? Since we are doing the same thing, we are using the for loop, we are traversing every element of our vector one by one, and we are incrementing to our map. So the time complexity, you would say, is big O of n. And similarly, at most, the size of the map can be the number of elements present in our vector. So the space complexity will also be equal to big O of n. So yeah,